Okay, let's talk about exponential functions. That's on your page 12. Page 12. Okay, so let's see. We are reviewing exponential functions from your math 154A. Okay, so first of all, what kind of things we call exponential functions? We have like we talk about if f of x equals like a base. If x is on the base, then to the power, so that kind of things we call it polynomials, right? So what kind of things are exponential functions? It's like this. So f of x equals what? 2 to the x power. So your variable is on the power position, exponential position. We call it exponential functions. So you might have like this, right? Different base, but your variable x is on the exponential position. So then we are going to graph those functions to see how they look like. At the same time, we will see some business applications, then possible applications, then for us to see how it works. Okay, so let's graph the first one, 2 to the x power. So how do we do? Just basic things. You use your t-table, x and y, right? So start from 0 to the 0 power is 1, to the 1 power is what? 2, 2 to the 2 is 4, and how about, oops, that's x is 1 or 2, right? Then if -1, -2. And what is 2 to the -1 power and 2 to the -2 power? Let's take a look. Then what does negative power mean? Okay, let's do more review before we get into the graphs. So let's review the powers, okay? Because exponential growth or decay, the x is on the power position. Then your variables can be what? Regular numbers or negative, or maybe even fractions. So that's a review. See, you still remember. Okay, so take a look. What does 2 to the 0 mean? Anything to the 0 power is 1. 2 to the 1 power multiplies itself once, twice, right? So like this, 2 to the 0 power, 2 to the second power. So that's first power is 2 and 4. What does 2 to the -1 mean? We say -1 doesn't mean -1. It means what? Reciprocal. 1 to the what? 2 to the 1 power, so it's 1/2, right? So 2 to the -2 power means what? 2 equals what? 1 to the reciprocal. So it's 1/4. So we learned those early on. So for the power. And second thing is you are going to use. So what happened is the power is a fraction. So it doesn't mean real fraction. It means what? It's a symbol. Top one means what? Power. Bottom one means the root. You learn this in 152A class. So it's 1 power to the 3rd root. So it's what? 2. Right? So if a to the 2/3 power, or you can do the root first, then do the power later. They are the same. So you can do the root first, do the power. So square root of third root of a to 2 to the second power is 4. What happened to the a to the negative 1/3 power? It's all symbols, right? They are all symbols. So negative means what? Reciprocal. So it's 1a to the 1/3 power. 1/3 power is the root of a, cube root of a, so it's 1/2. If a to the 2/3, negative 2/3, so what does that mean? 1 to the a to the 2/3 power. 2/3 power is 4, so that's 1/4. Okay. We also talk about, because we are talking about variable is in the power position, we have to, at the same time, we need to know how to operate on the powers, right? Am times an is what? How many a's you have? M plus n, right? Product property. So if power on power, what do you think? So 5 to the second power to the third, how many 5 you have? Total 6. How do you get 6? You multiply them. So power property. If division, am divided by an, how many left? Am minus n. So we learned all this previously. So we did a quick review on the power, how to operate the powers. So now let's take a look at how we are going to graph exponential functions. So for the first one, right? So you just do your t-table, then you find the points. So first one, 2 to the 0 power is 1. And 2 to the 1 power is 2. 2 to the second power is 4. 2 to the 3 power is 8. 4, 5, 6, 7, 8, right here. So 2 to the negative, x is negative 1. So it's half, right? 2 to the negative 2 is what? Quarter. So the graph will look like this. And getting smaller and smaller. And it doesn't matter how, how small the x is to the infinity. So if like 1 over what? X is say negative 100. So your 2 to the negative 100, right, is what? 100 reciprocal. It's a very small, close to what? 0. But doesn't matter how x will be to the negative number, then 1 divided over is always a positive and approach to what? Not infinity, it's approach to, number will approach to 0. So what happens is you will, approach to this line, x, that's your y, right? The number, this is your f of x, right? Actually, it's your y. So approach to that line, that's what happened, which it would be your what? Horizontal asymptote that we were talking about. So that's how he behaves. So that's the first basic exponential function. We learned this in 154A class. So how about second one? Okay, 3 to the x power. So x is 0, y is 1, x is 1, y is 3, x is 2, would be what? 9. Okay, so then if it's negative 1, it's 1/3 reciprocal. X is negative 2 would be 1 over 3/2, 3 second power. So your shape will look like this. right? So this one is what? 3 to the x power. First one would be 2 to the x power. Then let's look the fourth power, 4 to the x. So x is 0, 4 to the 0 power is 1. X is 1, y is 4. X is 2, y is 16. Then x is -1, y is what? 1/4. -2 is 1/16. So your graph will look like this way. That's your 4 to the x power, right? Doesn't matter how small the x would be, negative would be 1 over that number approach to 0. Okay, always above 0. So another thing we are going to learn is, so we are showing what? The exponential function, and take a look the graphs, how do they look like? So next one, we are going to, if it's this way, another function, base is e. What is e, right? You use the calculator and take a look. What is your e? So e, you might have e on your calculator, okay? Maybe on top of some buttons. So you hit that button, hit shift to that color and hit the button, okay? Or sometimes you just e to the 1 power, right? So the number is about what? 271,828. Try it and see you can get this number. You need to practice your calculator to do the homework, to do all that. So that would be e to the 2nd power, okay? And so if you use a basic calculator, then you might have, is what? You don't have this caret symbol, you might have what? Y to the x or x to the y, something like that, okay? There is button you can hit. So that would be, this number would be what? You need to practice this. If you have issues, and call me, then I can explain to you on the phone, depending on what kind of calculator you have. So that's for the e. We are going to use e to do a lot of applications, okay, base e. So if I graph the e to the x power, see, what's the number for e? 2.718 something. So it's between what? 2 and 3. Between 2 and 3. E to the 0 power is what? Still 1, right? So when x is 1, when x is 0, so your y is what? 1. So still go through this point. Then where is this line? Curve would be. E is between 2, E is 2.718, so it's between 2 and 3. So your graph should be what? Between the black line and the blue line. Should be somewhere there. Got the idea? Right? Okay. So we are going to talk about compound interest. Compound interest means what? You earn the interest. Then after the certain period of time, then you will earn interest on the interest, right? We use FV as a future value. So say if you have $100, okay, we make it simple, then I just use 12% rate per year, we wish, okay, interest. So after a year, how much money you will have, right? So for $100, you have $100, 12%, you got $12 for interest. You will have 112, right? So after second year, you will, based on the $112 you have, you earn the interest again. 112 you times what? Your interest equals what? Is 14, say 44. Then you add to 1444, so you actually have what? 126.44 cents, right? So the formula will look like this. So it's what? You have original $100, then you have this one principal plus what? 12%. That will give you 112, right? Then second year, you use 112 times what? Your principal, 112, then plus your interest, which is what? 1444. You multiply, you get this again. You get this amount. So every time you start from principal, you multiply your principal plus interest. You get this amount. Then this amount will carry over for next year. You multiply again. So it's like 100 times what? Your rate, right? First year times once, second year times twice, 3 years, you time more times. So that's your time formula like this. If you accumulate yearly. If you accumulate quarterly, say, quarterly, right? Quarterly, is that right? Okay, so 12% a year, quarterly, how much you can make? So 12% divided by 4. Each quarter, you only make 3%. But you compound it this way. So for first quarter, you add your 3%, right? Second quarter, you add another. Within this, we are talking about still first year, okay? Percent times what? 3%. So that would be your, still your first year, right? So in a way, how do you calculate? You do 100 times what? 1 times 3% to how many times per year? 4 times, right? Then for the second year, how we would do? So it will be what? 100 times 1 times 3%. How many times you actually compound? 2 years. Each year is 4 times. So that would be 8 times. So and so on. Third year will be 12 times. So your formula is this way. Okay? The future value is your value according to how much time you accumulate, right? So it's started from $100, it times what? 1 principal plus your rate. Depend on R is what? Say R, if R is your annual rate, right? So P is your principal. So how many times, depend on how many times you compound. If quarter, quarterly, so you get what? Annual rate divided by 4 times, right? If monthly, will be what? R divided by 12 each month. So depend on how many times. So if that's annual, depend on quarterly, will be divided by 4, and monthly will be divided by 12, right? Or daily, you divide by 365. So M is what? The number period per year, right? Per year will be compound, okay? Being compound. Is that right? Right? So that's how you compound. Compound how many times? Then like here, quarterly, 4 times, 4 times. Oops. Then monthly 12 times. So depending on how many times per year. So how many times you are going to compound per year. But we are calculating the future value depending on how many years down the road, right? So that's how many times. So 1 year, you quarterly 4 times. 2 years, you would do 8 times. So T is how many years you are going to compound. Compound, right? So that would be your formula, right? So your value is according to your time. So, like a function f of x, v of t. Where is your t position? Your t position is where? On the exponential position. As long as your variable is on the exponential position, what kind of functions we have? That's what we are doing. Exponential function. Okay? So, this is a compound interest formula. We will use this a lot. Then see some examples as well. Then another thing is what? It's called continuous compounding. What is that? So for the bank to do the business, it's like if you leave money there or credit card, they charge you, they might do, daily, and will be 365 for M over there. However, even daily may not be enough. They say, oh, I wanted to do it hourly or second by second. So future value, we have it this way, okay? If it's continuously, actually it's keep going, so we use this, okay? The reason behind it is complicated, okay? Maybe we take a look. It depends, okay? We can take a look. So that's your annual rate. So that's your future value according to your time. Take a look. Base is E. Where is your T position? Is on the exponential position. And exponential position means what? Your function is what? Exponential function. P is your principal. R is what? Your annual rate. Usually the bank, they will tell you, oh, what's our interest rate? Usually they give you by annually, okay? Then T is the years. So that's the formula we are going to use to calculate continuous compounding, okay? Then let's take a look how we are going to do that. Look at page 13. We are on page 13. So the constant E, actually, it was from here and to the infinity, and okay, the concept is about 2.718 to A, okay, 1A to A, some number 45. It's forever decimal either. Okay. So the reason behind it is extremely complicated, okay? So we are just going to leave as is, just give you some idea, very abstract things. Until you learn real calculus, then you can figure out what this limit means, what does infinity mean, okay? So it's on your page 13. If you are interested, then you can take a look. The reasoning behind it, okay? But the idea for us is we are going to see how we are going to apply it, okay? And the E is used for continuous compounding. Okay, so let's look at some examples how we are going to use these different formulas to find the future value. So for the first one, finding a future value. It says find the value of what? $4,000, right? Invest in the what? 2 years, right? Invest in 2 years. And 12%. It means what? Annual rate. Then we are going to compound quarterly. Okay? Then how many years? 2. So we are going to compound quarterly. It's not continuous. So we are going to use first formula. So $4,000 will be your principal, and 12% will be what? Your annual rate. And we need to what? Have M. M is what? How many times it will be compound per year. It says quarterly, so your M is what? 4. How many years we are looking at? 2 years. After 2 years, for $4,000, if you compound, you got a really good return on stock market. How much money you will have after 2 years? You just plug in the first one, right? So future value would be what? Your principal times your 1 plus R is what? 12%. You change percentage to what? Decimal, right? Your M is what? 4 divided by 4. So you get what? 0.03% per quarter. That's what it means. How many years? For 2 years. So you plug in, use your calculator, practice. How can you get a number? Okay? So you type in, if you cannot type one shot, you do it from inside to outside. So you at first do the power times this. Okay? All right, then you will actually have how much after 2 years? That's pretty good. From 4,000, and you get what? 5,000 some dollars. Okay, so that's finding the future value. Okay, second one on your page 14, finding present value. So let's see. It says finding the present value of $5,000 to be paid 8 years from now at a 10% interest compound semi-annually. What are we talking about? Say, okay, my kids just started, so I want to say, after middle school, I want to take them to Disneyland. So I want to have what? $5,000 by then, after what? 8 years, right? So I say, how much money if the CD say, oh, pay me 10% per year. So my annual rate is what? 10%. And how much money? It says, find the present value. This is what? 8 years later. That means this one, 5,000 is what? Future value, what I want at the time. So present value is how much money I need to put in to the account if it gives me 10% per year. Then 8 years later, I will have $5,000, right? So do I know the principal? We do not, because principal will be your present value, right? So then for the 10%, how do they compound for you, right? So you say semi-annually. What does that mean? twice a year, 2 times per year, right? So you use this formula. 5,000 actually is your present value. So we need to find the P. Then 1 plus annual rate 10% is 0.1. How many times per year? Twice per year. That's your M, right? So how many years? 2 8 years. That will be your function. So use calculator, and or if you do it by hand, that will be what? 0.1 divided by 2 is what? 0.05 to the 16th power, right? So you can use calculator to do the 16th power. So what's your P? P will be divided by 1.05 to the 6th power to the 5,000 into 5,000. So your P would be what? 2290. That sounds pretty good. If you put the money only 2,000 some dollars right now, if they give you a 10%, that's a big if, right? So after how many years? Only 8 years, you can get it to where? $5,000, more than a double. That's really good. That's how we find the present value with the formula, right? With the compound interest, which is what? Exponential function. Okay? And those are what? Exponential growth. What happened to decay? Right? So, like your cars, and it would depreciate each year. So let's take a look at the third one on your page 14, depreciation and asset. So if there is a new car, $30,000, it would depreciate the value by 40% each year. How much it worth after 3 years, right? So what's your T? 3 years, right? What's your P? That's your P, $30,000. P is your principal and current value, present value. What's your R? Annual rate. 40%, but it's depreciated. It will be depreciated, right? So it's negative, going lower and lower. Then how do we depreciate? Once a year. So what do we want to find is the future value, right? Is what? Use that formula, is $30,000, right? Times 1 plus, what's your R? -4. Once a year, how many years? So once a year, 3 years. So actually you have what? 30,000, right? 1 minus 0.4 to the third power. So that will be what? 6480. Well, it depreciates fast, right? If it's 40%, when you bought it, it's $30,000. After 3 years, it will only worth what? $6,000 or some amount. Got idea? So same thing, we do the same way to do the growth and the decay. Only the difference is the rate. If it's a positive, you have growth. If it's negative, it will be what? Decay, right? So look at the number 4. We are on page 14. So there is radioactive material, 210, right? It's in what? G isotope that will decay by about 13% each year. Meaning what? 13% of remaining the material transforms into another atom, right? And each day. So if we begin with what? 100 milligrams of the material, how much it remains after 1 week? So if it decays what? The rate by what? 13% means that's each day, 0.13, because it's decay, so it's a negative. That's each day, right? When we started, what's our quantity? That means present value. So we use what? Quantity at the beginning of time, we use 0. So you have what? 100 milligrams, right? So we are talking about after a year, not a year, a week. So because it's by day, so T will be what? A week would be 7 days. Okay? So we are doing the still like compound interest, but it's decay. So your Q will be what? That's a future value. That's a present value. What do you have? Plus what? 1 by R, because R is by days, then you have what? By the day. Okay? So what we do is your quantity will be what? 100, 1 minus your, because it's a negative, it's a decay. How many days? 7 days. So you end up from 100 milligrams, you will end up what? 3773 milligrams. That's how we handle the decay. Let's take a look the number 5. Finding a future value with continuous compounding. Okay, so let's see. Find the value of $1,000, right? At a rate of what? 0.8%, 0.08. Then continuously compounding. So for 20 years. So your present value, principal, that's your rate, right? T is what? 20 years. Annual rate always by the annual, right? Then this one would be 20 years. So once a year, that's what we are saying. Because for continuous compounding, we just use biannual rate and per year. Then according to this formula, so your future value would be what? Your 1,000, right? Use the base E. R is what? 0.08. T is what? 20. So you plug in your calculator, then you will get, of course, a bunch of decimals. But for the money, where you should stop by the pennies. So make sure you get this number, plug in, and get the right numbers. So that will be what? From $1,000, if continuous compounding, then after 20 years, almost 5 times that much. Okay. Same thing will learn another way. If I know future value, I should be able to find the present value, right? Another way around. So find the present value, $5,000 to be paid in 10 years at a 7% interest compound continuously. So find the present value. Say 10 years later, I expect what? I will have $5,000, right? Then equivalent present value, because you will have interest upon them to get that much money. So do we know the present value? That's your P. We don't know, right? So what's your rate? 7% per year. So change it to decimal. And t is what? 10. So we want to find the present value, it worth how much, which will equivalent to the $5,000 later, right? 10 years later. So how do we do it? Use the second formula. Future value 5,000 equals what? Your present value e to the rt. R is 0.07, t is what? 10, right? So that's 5,000 equals p e to the what? 0.7. So you divide it by. So you need to use calculator to find this value, to find your p. It's about, oh, it's not about. If it's for the money, you use exactly number to the penny. 2482. Make sure you can get the money numbers correctly. If you don't, call me. Then I will walk you through over the phone to figure out. So what we just did, we used different formulas from the present value to find the future value, or future value to find the present value. We also did what? Growth and decay as well, both of them. Okay, let's take a look how much difference between these two things, different way of compounding money. Okay, so we can compare which one will give us better return. So look at your page 15, number 7. We say, which gives a better return? Okay, one is what? 12% compound what? Quarterly, right? Another one is what? Oh, looks smaller. It only gives you 11.9%, right? But this one will compound what? Continuously. So sometimes they have less rate, but let's see which one will give you a better return. Okay, let's take a look. One is using what? Compound quarterly. So we just use $1. So I use P is $1, right? My rate is what? 12%, 0.12. Then we just do it 1 year. Then we can compare already, right? So if compound quarterly, what's your M? 4 times per year. So we use the first formula. What's your future value, right? So your future value is what? 1 times 1 plus your R is 0.12. 4 times a year. 4 times. We just do 1 year. We can compare two of them already. So for $1, then you can get what? 1255 if you compound quarterly. And let's take a look. If compound continuously, so P is 1, right? R is what? 0.119. We do 1 year because continuously it's counted by a year, by the years, right? Yearly. So we plug in. So what do we have? Your future value would be 1 times e to the r, 0.119, 1 year. So if you use the calculator, you will find out what? 1264. Which one is better? Even the rate is a little bit lower, but usually, actually, you get a better return, right? It doesn't look much difference, but if you have $1 million or billion, it will make huge difference. Got idea? Okay, let's look the number 8. So let's talk about decay. So, how do you say that? Radon? Okay, 222, some kind of radioactive material. They would decay. For those material, they would decay, not say quarterly, monthly, daily, hourly, because they will do it continuously, right? So if so, we need to use the second formula. So for the 100 milligram, and how much it will decay after 3 days. So we use this formula. The formula is what? Your quantity is what? And start from beginning, 0 time, times what? That's your principal, same thing, times RT, right? So you start from 100 milligram, your rate is what? 0.173, but it is decay, so we need to use what? Negative. For how long? So the decay rate is what? Per day. So your T will do it accordingly by days. So how many days? 3. So you need to identify those to be able to plug in. So you will do that, e to the negative, okay? So R times T. So on your calculator, when you type in the power negative, don't use minus sign. There is another thing on your calculator and look like minus sign, but it's for negative number. You need to use that button. Okay, so it's about 51.2 milligram. That's how we use continuous compounding to handle the decay. Okay, then for number 9, we wrote down everything for you, then you will read it yourself. So that will be on page 15.